Good afternoon, students. Welcome to GATE Prerana classes. Today class we will see about the engineering mechanics, second part. Here in last class already we seen about the different types of forces and then different types of the systems that has to be observed in our day-to-day life that has to be observed in the last class. In today's class we will see about the friction and then different types of the frictional forces that has to be observed. Let us start the next point. Now we'll see the next point. Here you can observe here force systems. Here you can observe the different types of the force systems that has to be observed. The different types of force systems: collinear, coplanar with like parallel forces, unlike parallel forces, and then concurrent forces, non-concurrent forces with different configurations, and then examples we've seen in the last class. These are all the resultant forces that has to be observed for the two different forces, that will be F1 and F2, with the constant resultant or that has to be find out in the last class itself. Now in today's class we will see what are the different types of the support and then what is the free body diagram. If suppose there will be any diagram which is resting on the ground, for that body there will be two forces that has to be observed. One is the weight of the force, another one be the reaction of the force. That has to be clearly observed here. One is weight of the force W, another one will be the reaction of the force R. Similarly, what is meant by moment? Moment is nothing but whatever the force that is to be multiplied with the perpendicular distance is known as force. Moment. Moment equals to force into perpendicular distance. Now we will see different types of the parallel forces. Example for theorem of Varignon or Varignon's theorem. Here in this Varignon's theorem, we will observe that the moment of a force about axis, whatever the moment of force of that axis, is equal to the sum of the moment of its component about the same axis. Here you can observe there is a two forces which are acting on the plane. There will be two forces will be observed here, and then some particular distance, there will be x or y distance. The two forces that has to be multiplied with each other, and then sum of the two moments is called as sum of the two moments at the same axis is called the Varignon's theorem. Similarly, here you can observe the parallel forces in a plane also. There will be equal forces that all will be applied in the same direction. A set of forces whose line of action are in same plane in which will be parallel to each other. You can observe here all are in upward direction, F1 and F2, F3, F4 like that are all in parallel direction, which will be the same action and then same direction. This is called as the parallel force system. Like parallel forces is nothing but the same direction, and then there will be with the same distance that has to be observed here. Their force, their magnitude will be equal. The forces can be equal and unequal in magnitude. That means F1 will be at x distance, F2 will be at z distance, like that we can consider here. That will be like parallel forces. Examples of like parallel forces are the trees. Next we will see the unlike parallel forces. When two forces act in the same opposite direction and the magnitude will be in unequal direction, then it is called as the unlike parallel forces. These are all the system of forces. They learn about these different types of the forces. For your competitive exam, they will give some figures and then they will ask you which type is which type of force. The next, unlike equal parallel forces. When two parallel forces act in opposite directions and are all in equal magnitude, then these forces are called the unlike equal parallel forces. The resultant of two like parallel forces acts parallel to them, but the position which will be observed will be divides the distance between their points of application, and then the ratios inversely proportional to their magnitude. Here you can observe here, there will be x, y and z direction. You can observe here two unlike parallel forces, and the resultant will lie outside the line of action, but the points which will be act will be the two forces that has to be in the same size of larger force. You can observe here, or and then there will be A and B point will be in XY zone with an angle of theta. Then their opposite force will be in the other side that has to be observed here. The next two equal parallel forces acting in opposite direction cannot be replaced by a single force. In such a case, two forces from a couple which has a tendency to rotate the body, then the perpendicular distance between the lines of action of the two forces that will be termed as the arm of the couple. If suppose we have to take the right hand thumb rule like that, if you observe that rule, then you will observe there will be one will be a force, another will be a distance, another will be in a different direction. These three will be equal, we will call as a particular couple of the system. Now we'll see what is meant by moment of a couple. Here you can observe there will be a point O is there. This will be in this point. This will be considered as A. Whatever the force we are applying will be F in downward direction, which is some distance of D. Another force will be there at a distance of F with a distance of D1 and D2. The rotational tendency. Suppose if you want to rotate the line, if suppose this will be a straight line will be there, the arrow mark, whatever the arrow mark will be upward, that will be we have to rotate in downward direction. The rotational tendency of the couple is measured by the moment. Moment is nothing but whatever the distance, whatever the force that will be multiplied with the perpendicular distance. Force will be in upward direction or in downward direction. That must be multiplied with the distance is called the moment. Force into perpendicular distance. F into D2 plus F into D. Or if you want the total, all the forces towards the A, then our moment of the couple will be F into total D. So it has to be checked here. F into D is the force into perpendicular distance. Now you can see the resolution or resultant of force. This all will be the same. The original force which are acting at a point A, which will be replaced with the force F, that will be applied to the another point of B. Here you can observe. Taking together with a couple of magnitude, whatever the force that has to be applied, that must be multiplied with the perpendicular distance. Force into perpendicular distance. This will give the lines of action between A and B point. Whatever the force we are applying here, that must be multiplied with the distance D to the other side. That force into distance is called the moment. Here you can see the diagram that will be in a curved shape. Now, the another topic that has to be observed here, up to now we considered only the forces and force systems. Now we'll see the friction. What is meant by friction? For every body there has a friction will be there. If whatever the force we are applying, oppositely resisting some force, that will be called as a friction. Here, friction is nothing but is a force that will be resisting the relative motion of solid bodies, fluid layers and material elements sliding against each other. That is nothing but here you can apply. This one will be the total weight of the body W, and then there will be normal reaction that will be in opposite direction. If suppose we are applying the force, either pulling force or pushing force, oppositely there will be friction will be, we can observe here. The opposite force that will be called as the frictional force. Whatever the force we are applying in the opposite direction, this will be our regular portion of force P. The opposite direction will be called as the frictional force. This is nothing but the friction. The resisting of the force that will be oppose the opposite force, whatever the force we are applying. This is nothing but the friction. It is the force distribution of the surface which will be contact and acts tangentially to the surface of the contact is known as the frictional force. Here you can observe the diagram. We are taking a ground. In this ground, we are keeping one box of weight W. Then automatically, whatever the force that has to be considered, there will be a normal reactional force will be there in opposite direction. Then we are pulling the force, pulling that box. We are pulling the box means automatically here you can observe the arrow mark that will be in opposite direction. the friction will be friction will be acting in this diagram. Or otherwise you can observe some diagrams. Suppose if you are sliding in a slider, then whatever the force we are using in that slider, due to gravitational force we will slide towards the ground. But our frictional force will act, it will be act as towards upward direction. That is the frictional force that has to be observed. For your GATE competitive exam, they will ask us about what is the definition of the friction, and then what is meant by coefficient of friction. Here you can observe the coefficient of friction will be different in different directions. If you are moving in the road will be a longitudinal direction. If you are taking the road surface, that will be a super elevation in transportation engineering. Then the lateral coefficient of friction will be changes. If you take the longitudinal friction also will changes when compared to the lateral friction. Here, first of all, what is meant by coefficient of friction? The coefficient of friction obtained symbolized by the Greek letter mu. Friction will be, we will be taken as mu, and then it is a dimensionless scalar quantity which has described the ratio of force of friction between the two bodies and the force of pressing them together. That is, F by N is known as the coefficient of friction. The coefficient of friction will be depends upon the material. If you are taking the ice, if you are sliding on ice, the friction will be more or less. If we are taking the steel, the friction will be low. Why means there will be a rough surface. If you take the glass, the friction will be zero. Why means there will be a smooth surface will be observed. While rubber on the pavement, that means while we are driving on the road, our vehicle has a wheel, that wheels will be with rubber. That rubber vehicles which we are moving on the ground, there will be high coefficient of friction. The coefficient of friction will be changes depends upon the material. Here, this coefficient of friction will be whether we are moving in the lateral direction or longitudinal direction. It will be depends upon the material and then depends upon the direction. Okay, friends. Next, we will see for the surfaces at rest relative of each other. What are the coefficients of friction that has to be considered? That will be equal to the mu s. That mu s is nothing but the coefficient of static friction. Now already you know what is meant by static. Static is nothing but a body which will be in a state of rest is called as static. Here also static friction is nothing but which a body will be in a state of rest with some opposed force. That force is called as a statical friction. Here in this we are usually larger than the kinetic counterpart. For surfaces in relative motion, we are considering that the kinetic friction, whatever the kinetic friction, that must be equals to the our relative motion of the friction. Mu equals to mu k. These are the conditions they will ask for your exam to give the correct statement. Whether mu is equals to mu k or mu is equals to mu s or not equal to mu and mu s. That is the coefficient of friction. Now we'll see dry friction. What is meant by dry friction? Dry friction is nothing but it is also known as adhesive friction. The friction between the dry surfaces in contact is called dry friction. That is nothing but the column friction. If you observe, the dry friction is nothing but the roads which we are moving in the ground at summer season. Both are in dry. Our vehicles will be in dry position and then our roads will be in dry. That type of condition will be called as the dry friction. The major cause of such frictions is believed that to interlocking of the microscopic prototubers, that is the minute projections of the surfaces which oppose to the relative motion, such prototuberance are also present. However, smooth the surface may be will call as the dry friction. If you observe the diagram, here you can observe the diagram, what are the force and then direction that's impending on the motion. Here we are pulling the force. We are pulling this object. While we are pulling the object, what will happen? There will be a frictional force will be acting in the opposite direction. This will be the direction of friction. This will be the direction of impending motion. Here you can observe the impending motion and then direction of friction will be in opposite direction. But the both are in the same zone. That has to be checked here. That is the dry friction. Now we'll see the another one, fluid friction or cohesive friction. This fluid friction is nothing but the friction which we observed in the liquid terms. That means another type of friction is the fluid friction. The friction between the two surfaces in the presence of fluid. The friction between the two surfaces in the presence of fluid is called fluid friction. That means if you are taking the boat in the water waves will be in one direction, but our boat or ship will move in the other direction. The moving of the ship and the friction will be in opposite direction. That has to be observed. That is called the fluid friction. Now we see the limiting friction. Limiting friction is nothing but the maximum friction that we have to be observed is called as the limiting friction. It is the maximum frictional force exerted at the time of impending motion. What is meant by impending motion? Impending motion is nothing but whatever the force that we are applying. What is the maximum force that we are applying? Then automatically opposing force also will give the maximum friction. The maximum frictional force exerted at the time of impending force or impending motion, that is when the motion is about to begin. Next we will see about the limiting friction. It is the maximum frictional force exerted at the time of impending motion, then when the body is about to begin, ready start to move is known as the limiting friction. The frictional force between the two forces surfaces are called kinetic and dynamic friction. What is meant by dynamic? Dynamic is nothing but when its body is in a state of moving position or in a state of motion, then it is called as dynamic. What is meant by static here? Same. Whatever the body which will be in a constant rest, then that condition, whatever we are applying the motion is known as the static friction. Now we'll see the 5 laws of friction. There will be 5 laws are there, what we learned here. First one is the total friction. This total friction that can be developed in independent of magnitude and the area of contact. Then the total friction, whatever the friction that has to be observed, that must be perpendicular to the proportional to the perpendicular of the normal force. Normal force is nothing but whatever the force that we are applying, that must be proportional to the frictional force. That is, F is directly proportional to N. To constant, F is equal to mu N. Mu is nothing but the coefficient of friction that we have to be learned here. F equals to mu into N. For low velocities, total friction that can be developed is practical of independent of velocity. Low velocities means there will be less weight and then less speed of the vehicle. For that conditions also we can observe the friction, but there will be low friction we can observe here. The coefficient of static friction is slightly greater than the coefficient of kinetic friction. Static friction is nothing but when the body is in a state of rest, and the kinetic friction is when the body is in a state of motion. It is general condition. When your body is in a state of rest, the friction will be very less. When the body is in a moving position, the impending position, then automatically friction will be more. Here, this will also, they will ask for your competitive exam for bits. Coefficient of static friction is greater than the coefficient of kinetic friction or less than or equals to or similar, that means proportional to each other. Like that they will give the question. This will be one important point. The next, within the rather larger limit, kinematic friction is independent of velocity. The friction which will depends upon the nature of surfaces in contact. What is the nature of surface? Whether the body is in a smooth condition or rough condition, depends upon that the friction will be changed. Now we'll see angle of friction. Angle of friction is nothing but here you can observe the slider. This will be a slider you have to think. It is defined as the angle made by the resultant of normal reaction and frictional force with normal reaction. If here you can observe, here we are keeping a box and then when we are lifting up at a certain angle, the body tends to move. The body tends to move is known as the angle of friction or angle of repose we will call it. This will be tan phi equals to mu s. That will be when a body is in a state of rest, that will be static position. Whenever we are applying some force to lift our slider, then automatically the body just tends to move. This tending of the position, moving of the position is called as the angle of friction. The sense of friction is always opposite to the sense of the impending motion. See here, you can apply whatever the force we are applying in upward direction, then automatically the body tends to downward direction. Whatever the force comes to downward direction, the friction comes upward direction. This will be one type of angle of friction. Now we will see the next one. Here the two bodies, we are considering the two bodies which are involved both. They are showing that tendency to move with represent to each other with normal reaction as well as frictional force, which will be acting of the two bodies are equal in magnitude and equal in direction. That means the two bodies of same weight and then they both are in opposite directions, they are moving. Then that force, whatever the two bodies will move opposite directionally, then it will tend to move with respect to the normal reaction. Here you can observe whatever the force you are applying in the right side, then it will move in the left side. If you are moving the left side, then the frictional force will be in the right side. The two combinations will be act at the center. Next one is the belt friction. This will be observed in our wells, rope and well. Okay, you can observe here. This will be a rope and this will be a wheel. Wheel and rope, we can observe this one. Look at this flat belt passing over a drum. Let's take a look of differential element of motion that will be assumed, that will be impending the motion in towards. Towards right side we are moving and then towards left side it will be some tension will be observed. The normal force is different because of the differential elements of area. Integrating the above contact angles, there will be different methods will be observed here. Okay, different formulas will be there for the flat belts passing over the drum and then ropes wrapped around the post or capstan. Some band breaks will be observed here with the rotate of the band remains fixed. Problems involving the belt drivers will be pulley and belt rotate and then it determines whether the belt will slip or move the pulley. If you are taking a drum and then we are taking one rope, we are moving from left to right, there will be some changes will be observed. That will be a belt friction. Now we'll see another one that will be a rectilinear motion of a particle. Rectilinear motion is nothing but this will be depends upon the motion of the body. A rectilinear means the motion, the body which will be moving from one place to another place. That is nothing but the dynamics. Dynamics is a part of the mechanics that deals with the analysis of bodies in motion. We learn about the dynamics here with the motion of the bodies. This dynamics is already, we know, divided into two types. One is kinematics, another one is kinetics. And then we know about the kinematics. Kinematics is the study of the relationship between the displacement, velocity, acceleration and time of a given motion without considering any forces that has causing the motion is known as kinematics. Kinetics is nothing but the relationship between the force acting on a body, the mass of the body and the motion of the body. This kinetics therefore can be used to predict the motion that will be caused with a given force, to determine the forces required to produce a prescribed motion. Without causing any motion, without causing any force, the body has tends to move is known as the kinematics. With force, we are applying some force, it will move, then it is called as the kinetics. The science of dynamics is based on the natural laws governing the motion of the particle. The term particle is convenient idealization of the physical object, which will lead the small size and then idealization of the size, that it has to be negligible. Now, automatically we see in dynamics there will be two parts, that is types of motion. When a particle moves in space, it describes curve curve called path. This path called the straight or curved path. Whatever the motion of the body will be in a straight line, that is called as a rectilinear motion. That means when a particle moves along a path which is straight line is called rectilinear motion. Curvilinear motion is nothing but when a particle moves along a curved path, it is called as a curvilinear motion. If the curved path lies on a plane, it is called as a plane curvilinear motion. That has to be observed. Then kinematics is based on the displacement. Here this will be, we can consider the different parts that has to be observed. Kinetics is without considering of the force. According to our GATE syllabus, next we have to go about the centroid and center of gravity that we will see. According to our GATE syllabus, first you had to know about the system of forces, and then you had to know about the statics, whether the body is in a rigid position or the body is in a motion body. That will be in dynamics. That has to be learned in the statics in engineering mechanics part 1. And again some basics about the force system. That will be different types of the force systems, coplanar, collinear, the next parallel forces, like parallel forces, unlike parallel forces, that like that. Next part of the engineering mechanics, you have to know about this centroid and center of gravity. This will be one of the most important topics, and then based on this, they will ask for your, if suppose if you are writing IAS exam, there they will ask us for question and answer, questionnaire type. In this questionnaire type, first you have to know what is meant by centroid and then what is meant by center of gravity. In general, you can observe, if you are taking a book, you can find the center of gravity of the book. If you are taking a paper, then you can find the centroid of that paper. How is it possible? If you are taking now with weight, that will be a 3D condition. The entire weight of the body is assumed as a concentrated, and then total weight will act at the center. That the total weight of the body will act towards the ground, then that is called as the center of gravity. If you take a paper that is a 2D plane, then we have to fold in different directions. There will be automatically centroid will form for that particular point. The total body will act at that particular point to calculate the area and then to calculate the volume is called as the centroid. Okay, now we can see the definitions of centroid and center of gravity. Centroid is defined as a point about which the entire line, area or volume is assumed to be concentrated. That means you have to take a paper and you have to fold. If you fold in horizontal direction or vertical directions, two sides, then you will get one center point. That center point is the centroid of your paper. Similarly, if you are taking a book, here you can see the book, that will be center of gravity. It is defined as a point about which entire weight of your body is assumed to be concentrated. The total weight of the body is 10 kg of the book, 10 kg book you are taken. The total 10 kg will act towards downward direction due to the gravitation. That is the centroid you can find of that body weight. Here centroid will find about the line of action. Okay, this is the main difference between the centroid and center of gravity. Here you can see the another point. It is related to the distribution of length, area and volume. If suppose if you are taking the square shaped paper, the square shaped paper, the centroid will be a different condition. If you are taking a triangle paper, for that triangle paper, the centroid will be where we are meeting the point, where the diagonals meet at one point, that point is the centroid. Similarly, if you are taking the 10 kg of book, the centroid will be, center of gravity will be at center of the mass. If you are taking the water bottle height, weight, and then based on that, the center of gravity will also changes. It is related to the mass distribution of mass, center of gravity. It is related to the distribution of length, area and volume. Okay, students, you can know about these two differences, centroid and center of gravity. Here you can observe the diagrams. Here one bottle is there. You can observe the bottle. And then there will be some water will be observed here. Then the total center of gravity will be CG here. If you are twisting the bottle, then what will happen? Whatever the bottle has to be at center, this will be center of gravity. If you are twisting the bottle total bottle weight will be twisted here. Twisted means torque, moving of the body. The pull of gravity we can observe here. From which direction we send? We moved this one, and then here you can observe in this direction. The movement of this body and then the center of gravity, that also has to be observed clearly here. But if you are taking a centroid will be here. There will be some other point. But center of gravity will changes, depends upon the direction and then depends upon the weight. Up to here, it is centroid, the center of gravity will be at center. Here we are rotating on the right side, then it will be on the right side. If you are moving on the left side, the body, then automatically the center of gravity also will changes. Now we can see a man which is moving on the rope. Here, how he balanced. He balanced the stick and then how he is moving from one position to another position. You can observe here the body and then the weight of the whatever he is taking in the stick and then how he is moving with balanced and then with whatever the force that has to be applied and then how he is moving with the center of gravity. The main cause and then the movement will be depends upon the size. Here you can observe clearly. Here you can see the center of gravity and then center of buoyancy. Center of gravity, here you can see a boat is moving. This will be unstable boat. This will be a stable boat. Here for a stable boat, the two persons are standing at the center of buoyancy at center, and the total stable condition, the total body will go towards the downward direction of their gravity. This is the center of gravity. If you observe the unstable boat, the two persons which are standing here, they will move here and there. Their center of gravity and then total weight of that body will also move from one position to another position. The center of buoyancy also will change from one position to the another position. You can observe the diagrams here. Here the center of buoyancy and centroid will be at same point. Here the center of buoyancy will be changes from another position. Here also you can see the different figures. Similarly, what is the stable and unstable condition with centroids. Now we'll see the axis of reference. Whenever we are considering the centroid, we have to know about the centroidal axis, that is axis of reference. Here you can see the center of gravity of a body is always calculated with reference to some assumed axis. That means whether we have to assume with reference to x-axis or we have to take with reference to y-axis. The axis of reference of plane figures is generally taken as lowest line of the figure. That means we have to calculate whether we want to calculate the y direction, means you have to calculate the x bar. If you are taking the horizontal, then you have to calculate the y bar distance. And then here you can see the centroid, center of gravity. Then here we are considering a system of n particles which are fixed with one region of a plane. The weights of the particles can be represented by the single equivalent resultant weight, which are having a definite centroid that will be z. The total will act towards the downward direction. Here we are considering the one plane and then we are taking one element that will be a weight of dw. Okay, the weight will act towards downward direction, that will be zx. Then we have to consider the x-axis and y-axis, means again whatever the load that we have applied with respect to the angle, that has to be considered here as the center of gravity. Here you can see the total weight of the particles that will be comes under the total body, that is WR, that must be equal to the integration of dW. Integration of dW is nothing but the moment of the body which we are calculating in x direction or y direction. If suppose we are calculating on the x-axis, then it has to be considered as xWR. That means x bar, whatever the centroidal distance at that point with respect to the x-axis, x1 W1 plus x2 W2 plus x3 W3, like that. If you are considering the moment about the y-axis, then our value will be y bar into WR. That will be y1 W1, y2 W2, like this has to be considered here. If suppose if you are considering the center of mass, not centroid, center of mass is nothing but the x bar equals to integration of x bar into dm moment with respect to integration of dm. Like that it has to be considered. Similarly, if you consider with respect to the volume also x bar if you want means integration of volume x bar into dv by dv. If you consider with respect to area, then similarly you have to consider x bar equals to x in x1 into dA by d integration dA. If you consider with respect to line of centroid, the line of centroid will be with respect to the distance. These are all the formulas that has to be remembered and then you have to be applied for your exam. Here you can see the axis of symmetry. If you take the I-symmetrical section, I section, whenever we are folding the I section towards horizontal, what will happen? This top will be equals to the bottom. It will be two T shapes you can observe. Okay, similar direction, similar length and then similar heights. If you are folding towards right, that means if you are folding in the Y direction, then the two sides will be a C shape. This will be a axis of symmetry of the centroidal point. This will be the axis of symmetry. For different shapes, there will be different angles and then there will be different centroidal formulas will be there. You had to remember the formula and then you had to apply for your exam. If suppose they will give any semicircular arc, the arc of the semicircular length you have to be considered means pi into r. Then if we suppose if we want to consider the x bar, that is centroidal towards x-axis means the radius of the arc. Xc equals to r, and then if you are considering the c, yc equals to 2r by pi. These are all the formulas that has to be considered here. If you are taking the quarter circle arc, for that quarter circle arc, the length of the arc will be the pi r by 2. And then our centroidal distance will be 2r by pi and the y-axis will be 2r by pi. These are all the formulas that has to be learned in the starting from the 10th standard onwards. Next we will see the circular arch. Here in this circular arch, if you are considering the length of the arc is 2r alpha. If you are considering the y distance means there will be no y distance, no axis that has to be considered for the circular arc in y direction, that will be equal to 0. If you consider the circular arc with respect to the x-axis, our formula will be or sin alpha by alpha. These are the formulas that has to be considered for the rectangle, for a circular arch, quarter arch, and then another similar arc. Now we'll see, we are taking a rectangular area. That means if we are taking a paper of length 10 meters and then width 5 meters. Then what is the area of the rectangle? Area of the rectangle, all of you know about the area of the rectangle is length into breadth. Here B into H. You can observe here the area of the rectangle is L into B or B into H. If you are considering the centroidal of the x-axis, x bar, if you want x bar, our formula will be whatever the x distance, length distance by 2. X bar equals to B by 2. If you want to consider the y bar, yc, the centroidal axis towards the y direction, yc equals to h by 2. This is the formula to calculate the yc and xc. Similarly, if you are considering the centroid for the triangle shape, the centroidal shape of the triangle, what is the first area you have to calculate? Area of the triangle is half into base into height. dh by 2. This is the area of the triangle. Then whenever we are considering the centroidal distance from the tip, here you can consider this will be the x-axis. Here we are considering x equals to, the formula will be 2b by 3. Yc will be from here h by 3. From tip we are considering here, this will be h by 3. From this direction xc, this will be 2b by 3. Okay, this is the formula that has to be remembered and then you had to apply directly in your problems. Next we will go for the semicircular area. The area of the semicircular will be pi r square by 2. And then the xc, the coordinate, centroid of the x-axis will be radius of the circle. That means small r. Centroidal of the semicircle in x-axis equals to radius of the circle r. If you consider in the y direction, centroid of the YC equals to 4r by 3 pi. This is a formula that has to be calculated in the centroidal unit. Similarly, for quadrant of circle, area of the quadrant circle equals to pi r square by 4, and then in x direction it will be 4r by 3 pi, in y direction also 4r by 3 pi. These are all the formulas that has to be remembered for your exam. The next circular arc, area will be r square alpha, XC will be 2r sin alpha by 3 alpha. Here we can see the circular sector. For this sector, area of this circular sector A equals to r square alpha, and then horizontal direction XC equals to 2r sin alpha by 3 alpha. That will be considered here. Here for spandrel parabolic shape, the area of the spandrel parabolic shape formula will be 1/3 of B into H. Normal regular parabolic, I will show you. This will be 2/3 B into H. Spandrel means 1/3 B into H. That has to be remembered. And the x direction will be 3b by 4. Y direction will be 3h by 10. Here x direction will be 5b by 8, and the y direction will be 2h by 5. These are all the different centroidal formulas that has to be considered. Next, now we'll see here rectangular parallelopiped condition. That means if you are seeing here with the 3D dimension. Whatever we seen in the last one is the 2D dimension of the rectangle. There we consider directly area of the triangle is area of the rectangle is B into H. But here we have to consider the volume of the rectangle parallelopiped. Volume is length into breadth into height. A into B into C. You can observe here. Then we have to be calculate the centroidal x-axis. Here you can see the x-axis means b by 2, y-axis means x-axis means a by 2, y-axis means b by 2, z-axis means c by 2. This is the half of the distance of the each direction. Now we can see the circular cylinder. Here also we are considering the volume of the circular cylinder, that is a 3D shape. Pi r square L. Pi r square L we are considering. Here the total object will be in x direction only. There will be no centroidal of the x direction, that will be equal to 0. If you consider the y direction, the centroidal of the y direction will be L by 2, and the z direction will also be 0 for the circular cylinder. Now if you go for the hemisphere, the volume of the hemisphere formula will be 2 pi r cubed by 3. Here there will not be any x direction and y direction of the centroidal distance, only the z direction will be there. That z direction will give us 3r by 8. Similarly, you can see a right circular cone. If you are taking a cone shaped pyramid, for that you have to calculate the volume of that pyramid. How will you calculate the volume? What is the radius of that pyramid shape? That is pi r square into h by 3, which at what distance? At 1/3 distance. That's why volume of the circular cone will be pi r square h by 3. Then there is a horizontal condition, and then there will be a z condition will be there. Both x and z will be equal to 0. There is no centroids for x and z. Only y direction there will be a centroid will be there, that will be 3h by 4. Okay, these are the different conditions that has to be observed. Now, if you have a pen and paper, all of you do this one. Determine the coordinate system of center of gravity of the object as shown in figure. Here they gave a shape, that is H shape they gave of different dimensions with, you can observe the x coordinate and y coordinate. Okay, what is the dimension of this one is 2 meters, 2 centimeters, height will be 6 centimeters. Here this will be 4 centimeters, height will be 2 centimeters. Then another one is 2 into 6. Here you can see, first you have to divide the diagram. Whatever the diagram given, for that diagram first you have to take the areas. If suppose I am taking from the right to left, this will be one rectangle 1, this will be a second rectangle and this will be third rectangle. First I will calculate the area of this rectangle 6 into 12, then I will take the another rectangle 4 into 2, then I will take another rectangle 6 into 3. Here you can observe A1 2 into 6, A2 4 into 2, A3 2 into 6. Then next I want to take the center of point lies on the x-axis. Center of point lies on the x-axis, you can observe here. From this point I am taking, this will be my x-axis. First one, for this 2 by 2 is a half. That is, 1 is my first centroid. Next I am taking for this rectangle, you can say the second run, 2, whatever the 2 first rectangle will be there, that plus 4 by 2. This will be 4 meters. First one is 2 meters plus 4 by 2. Here is my x2. And then on the third x3 will be whatever the 2 plus 4 plus 2 by 2. That means 7 is my x3. x1 is 1, x2 is 4, x3 is 7. Okay. Whenever we are taking the x1, x2, x3, I want to consider from the y-axis. Y-axis నుంచి calculate చేయాలి. ఇది y-axis అయితే నేను x1 calculate చేసేటప్పుడు ఈ rectangle కి half distance తీసుకుంటాను. నెక్స్ట్ rectangle కి ఫస్ట్ rectangle ప్లస్ సెకండ్ rectangle లో half తీసుకుంటాను. థర్డ్ rectangle తీసుకున్నప్పుడు ఈ 2 rectangles ప్లస్ ఇక్కడ తీసుకోండి. మనం తీసుకున్న ఏ సెంట్రాయిడ్ అయినా కూడా టువర్డ్స్ ద ఆబ్జెక్ట్, టువర్డ్స్ ద యాక్సిస్ నుంచే తీసుకుంటాం. ఇది x1, x2, x3. నెక్స్ట్ y1 చూడండి. y1 తీసుకున్నప్పుడు ఫ్రమ్ బాటమ్ అంటే x యాక్సిస్ దగ్గర నుంచి తీసుకోవాలి. y1 ఫర్ దిస్ డైరెక్షన్, y1 అంటే టోటల్ వచ్చేసరికి 6 meters, 6 లో సగం 6 by 2. 6 by 2 equals to 3. Here you can observe that 6 by 2 equals to 3 meters. నెక్స్ట్ ఇక్కడ చూడండి, నేను ఈ రెక్టాంగిల్ కి తీసుకోవాలి అంటే ఈ రెక్టాంగిల్ కి రిమైనింగ్ ఈ కింద నుంచి తీసుకోవాలి నేను ఫ్రమ్ బాటమ్, ఫ్రమ్ ఎక్స్ యాక్సిస్. కాబట్టి 2 plus 2 by 2. 2 plus 2 by 2 అంటే 3 meters. Here you can consider y2 equals to 3 meters. Next, if you go for the last one అంటే ఈ లాస్ట్ రెక్టాంగిల్ కి దీనికి y కావాలి అంటే టోటల్ 6 by 2 that equals to 3. ఫస్ట్ ఏం చేస్తాము, ఫస్ట్ మనకి ఇచ్చిన డయాగ్రామ్ ఏరియాస్ క్యాల్కులేట్ చేస్తాం. ఇది దిస్ వన్ విల్ బి ఫస్ట్ వన్ ఏరియా ఆఫ్ ద రెక్టాంగిల్ అండ్ దెన్ సెంట్రాయిడ్ ఆఫ్ ద రెక్టాంగిల్ ఎక్స్ యాక్సిస్ వై యాక్సిస్ కనుక్కున్నాం. ఏరియా ఆఫ్ ద రెక్టాంగిల్ ఎక్స్ వై. నెక్స్ట్ సెకండ్ రెక్టాంగిల్ ఎక్స్ వై డైరెక్షన్, థర్డ్ రెక్టాంగిల్ ఎక్స్ వై డైరెక్షన్. ఇక్కడ చూడమా, సేమ్ వీఆర్ కన్సిడరింగ్ ఫస్ట్ వీ డివైడ్ ద ఆబ్జెక్ట్ ఇంటూ 3 parts. వై యాక్సిస్ నుంచి ఫస్ట్ పార్ట్ తీసుకున్నాం, దాన్ని part 1, దాని ఏరియా, దాని x1 వాల్యూ, then y1 value. Next, second part, then x1 value, x2 value, y2 value. Next, third part, x2 value, x3 value, y3 value. If only we calculated the areas and center points. Then, మనం ఏం క్యాలిక్యులేట్ చేయాలి, సెంట్రాయిడ్ క్యాలిక్యులేట్ చేయాలి. సెంట్రాయిడ్ క్యాలిక్యులేట్ చేయాలి అంటే కోఆర్డినేట్స్ ఆఫ్ సెంటర్ ఆఫ్ గ్రావిటీ అబౌట్ ఎక్స్ యాక్సిస్ అండ్ అబౌట్ వై యాక్సిస్. ఎక్స్ యాక్సిస్ లో సెంట్రాయిడ్ ఎక్కడ వస్తుంది, వై యాక్సిస్ లో సెంట్రాయిడ్ ఎక్కడ వస్తుంది అనేది మనం క్యాల్కులేట్ చేయాలి. ఎలా క్యాల్కులేట్ చేస్తాము, ఎక్స్ బార్ ఈక్వల్స్ టు a1 x1 ప్లస్ a2 x2 ప్లస్ a3 x3 డివైడెడ్ బై ద a1 ప్లస్ a2 ప్లస్ a3. దిస్ ఇస్ ద సెంట్రాయిడల్ ఫార్ములా. Similarly, y bar you have to calculate means y1 a1 plus y2 a2 plus y3 a3 divided by a1 plus a2 plus a3. Then you have to substitute the values and then you have to calculate our coordinate of center of gravity, that where it has to be applied. ఇప్పుడు మనం డయాగ్రామ్ చూస్తే మనకు వచ్చిన సెంట్రాయిడ్ ఎక్కడ టోటల్ డిస్టెన్స్ వచ్చరికి 8 meters. మన సెంట్రాయిడ్ ఎక్స్ యాక్సిస్ లో 4 meters దగ్గర ఉంది, y యాక్సిస్ లో 3 meters దగ్గర ఉంది. అంటే ఇక్కడ నేను ఎక్కడైతే ఆరో మార్క్ పెట్టినో హియర్ ఈస్ అవర్ సెంట్రాయిడ్ దట్ హ్యాస్ టు బి calculated and then we find the centroidal distance of this H section. Okay, similarly we had to do for different types. Here they gave one triangle, in that there will be removed one rectangle. For this what we had to calculate? First we had to calculate the triangular sectional centroid and then we had to minus the rectangular section. Here you can observe this one. We had to be observed y will be 2. Similarly, different problems that has to be done for your GATE exam with different shapes. Okay, next one we will go for the center of mass and centroid. This is the Pappus theorem. Theorem of Pappus, this already we learned and then we listened this one. Theorem of Pappus is nothing but it will be depends upon the area, volumes of revolution. The method of calculating a surface area which will be generated by revolving a plane curve about non-intersecting axis in the plane of curve is known as Pappus theorem, depends upon the area. If you are taking the calculating of volume generated by revolving of an area about an intersecting, non-intersecting axis in the plane of area is known as the volume method. One is area method, another one is volume method. You can observe here the sphere that has to be considered in different directions. The formula of the sphere, first surface area, A equals to 2 pi y bar into L. This is a theorem 1 of Pappus. A equals to 2 pi y bar into L is our formula. This theorem of Pappus can also be used to determine the centroid of plane curves if area created by revolving these figures with non-intersecting axis is the center of mass and centroid of surface area with theorem 1 of Pappus. This is the first theorem, Pappus theorem. Second one is the second theorem of Pappus theorem will explain about the volume. Here the volume of that element that will have gives the circumference with respect to the differential areas. Once we had to calculate the volume, we had to take the dV equals to 2 pi y into dA. Then volume of the total element will give V equals to 2 pi y bar into A. The volume of the body of revolution is equal to the length of the generating area times and the distance traveled by the centroid of the area while the body is being generated. Then it will give with some slope and then with some y direction multiplied by the area gives the second theorem. Okay, these are the two theorems that have been asked here. Next one is area of moment of inertia. By using the formula m equals to k into integration of y square into dA. By using the calculating the moment of inertia with x-axis, integration of y square into dA, and y direction also integration of y square into dy. Then polar moment of inertia. The formula is very important. That will be in z direction. The polar moment of inertia Iz equals to integration of r square into dA. Whenever we are taking a particle dA element, that particle where we are calculating is integration of r square into dA. This is one of the most important point of polar moment of inertia formula. And then the polar moment of inertia is related to the rectangular moment of inertia. That rectangular moment of inertia will give us Ix plus Iy. The total moment of inertia of an area is purely a mathematical property of the area and itself has no physical significance here. There will be some different directions will be observed here. What is meant by radius of gyration? For 2 marks and then for bits they will ask the radius of gyration. Radius of gyration is nothing but whenever the square root of the moment of inertia with respect to the area. Here you can see Ix. The Ix is nothing but the imagine that the area is concentrated in a thin strip parallel to the x-axis with respect to the equivalent direction. Ix equals to kx square a, where kx is the radius of gyration with respect to the x-axis. Here all of you please see the diagram. Here there will be an x-axis. One element we are taking at some distance of kx. This will be x direction means this will be y. X direction means this will be kx. This will be kx and this will be ky. The element area will be A. The moment of inertia of this will be Ix we are considering. That Ix equals to kx square times multiplied by the area. That kx equals to square root of Ix by 8. For your exam, they will give the moment of inertia of the element will be 10 mm over 4 and the area will be 2 meters square. Then you have to find the radius of gyration. Our formula is kx equals to square root of Ix by 8. Ix is 10 divided by 2. Then is 10 by 2 is the 5. Root 5 is our radius of gyration. That formula has to be, by using the formula, we can find the radius of gyration in x direction, similarly in y direction. You can observe here. K equals to square root of I by A. This is the main important formula for the radius of gyration. Next, the radius of gyration K is measure of distribution of area from a reference axis. That radius of gyration is different from centroidal axis. If you are taking a strip, that strip will be in a rectangular form, the radius of gyration will change. If you are taking a square shape, the radius of gyration also will change. If are different, depends upon the shape, the radius of gyration will change. Now we see here area, moment of area of the rectangular, triangular section, our formula. This formula, I think all of you know about this moment of inertia of a triangle with respect to its base. Ix equals to bh cubed by 12. Directly you can remember this formula and then you can substitute the moment of inertia for a triangular section. Ix equals to bh cubed by 12. Where b is the base of the triangle, h is the height of the triangle, and then can calculate the centroidal axis at x distance. Ix equals to bh cubed by 12. Similarly, if you go for the circular area, the area will be depends upon the circle. Ix equals to pi r over 4. The next moment of inertia also depends upon the parallel axis theorem and perpendicular axis theorem. Here the perpendicular axis theorem will give us Iz, which direction at z direction we are taking. With respect to x and y, Iz equals to Ix plus Iy. If you take the parallel axis theorem I equals to I bar plus AD square or AH square will call. This parallel axis theorem, by using the second moment of theorem, I equals to I bar plus AD square. These are the formulas and then formulas for different shapes based on the parallel axis theorem. For a circular shape, 5 by 4, pi r power 4. For a triangle, bh cubed by 36. For square shape, our value will be bh cubed by 3. In x direction and y direction, and the moment of inertia will changes depends upon the x bar and y bar. Whenever we are considering the moment, we have to consider whether we are considering from base or we are considering from the centroid. If you are considering from the base, our value will be bh cubed by 3. If you are considering from the centroid, our value will be bh cubed by 12. Okay, that's only the small difference you have to remember. Whenever we are considering the moment of inertia, whether we are considering from bottom, bh cubed by 3. Whether we are considering from the centroid, the moment of inertia is considered from centroid, bh cubed by 12. Similarly, you can go for the triangle shape. Moment of inertia for the triangle about the x-axis. X-axis means from bottom. X-axis means from bottom. If you are considering from bottom, our formula is bh cubed by 12. If you are considering from the centroid, we are considering the moment of inertia. This will be the x dash axis. Then our formula will be bh cubed by 36. Okay, these are all the formulas that has to be remembered and practice, and then they will give some values. They will give one rectangular shape and then breadth and height shapes, and then they will ask us to calculate about the centroid. So to calculate the moment of inertia at centroid. At centroid means Ix bar, that equals to bh cubed by 36. There has to be substitute bh cubed by 36. If suppose they will ask us to calculate from the bottom, our formula is Ix equals to bh cubed by 12. Okay, these are the formulas that has to be used for this calculating the moment of inertia. Similarly, for circular shape, Ix equals to pi r power 4 by 4. Z-axis, I naught equals to pi r power 4 by 2. For semicircle, pi r power 4 by 8. Similarly, for Z-axis, pi r power 4 by 4. For quadrate circle also, pi r power 4 by 16 has to be considered. And then for ellipse, Ix equals to pi ab cubed by 4, Iy equals to pi a cubed b by 4, and z direction pi ab by 4 into a square plus b square. Okay, these are the different formulas that have to be remembered, and then you have to do the different problems for your competitive exams and then main exams by using the different calculations. Okay, students? These are the basics that has to be learned, and then these are the formulas that has to be used for the standard tabular example to consider the moment of inertia and centroid. This is the total topic of the engineering mechanics. Next, we have to go for the strength of materials and structural analysis in the next class. Thank you, students. Thank you for listening to the class.